Thank you very much. I'm so glad to be following two excellent speakers and talking about stress too, my favorite subject. I don't have to tell you much about the motivations for looking at social inequalities in health, but I will be talking about whether stress could be an explanatory factor, talking about what I think to be the research gaps in this literature, which is about adaptation to stress, and showing you some empirical analysis using data from the English longitudinal study of aging. For those of you who come from the social inequalities in health literature, you might be familiar with this kind of finding from the first Whitehall study that showed that even in a rich country like the UK, even in a stable job like the civil service, you find very stark occupational grade differences in mortalities between the top administrative civil service grades and the other grades. So these are men largely working in the postal room or messengers, but they had stable jobs. They had high, relatively high incomes, and you can see that even well after retirement, which is age 60 for this group, there were still remain very stark occupational grade differences in mortality. So that was the first Whitehall study. The second Whitehall study was set up to investigate the reasons for such social inequalities in health. I worked on the study in between 2001 to 2010, so I was involved in 4 waves of data collection on this panel study. And my job was partly to also explain these occupational grade differences in this cohort. So here's an example of physical health on the top and mental health at the bottom. As people age, these occupational grade differences actually widen in early old age rather than becoming narrower. So what I was interested in is looking at whether or not social class could be a factor here in explaining stress. And the idea was that if you are poor, deprived in the more disadvantaged occupational groups, you would have higher rates of stress. And when we looked at that in the Whitehall study, it was actually the reverse. The question was, how much stress did you have in the last 4 weeks? And surprise, surprise, those in the top grades said, yes, I'm the most stressed out person you can imagine. And as you went down the occupational hierarchy, the levels of perceived stress dropped. Of course, stress is not such a great question. We should really be looking at the stressors, financial, working, living stressors. And when we start looking at that, a more nuanced picture arrives. So if you look at job demands, it's unsurprising that those at the top report higher levels of job demands. And as you go down the occupational hierarchy, the levels of job demands decrease. But in terms of job control, it's actually the other way around. So having low levels of job control is a stressor. And we see a very strong occupational gradient in levels of job control. And for those of you who are familiar with the work stress literature, it's the combination of having high job demands and low job control that is particularly bad for cardiovascular health. And here it's going in the entirely the expected direction. So the top civil servants in the unified grades 1 to 6 have the lowest levels of job strain. And as you go down the occupational hierarchy, the levels of job strain increases. So that's in relation to self-reported stressors and self-reported stress. What this study was particularly interested in was not just the self-reported measures, but also the biological measures of stress. And for that, we relied a lot on Bruce McEwen's model of allostatic load. So stress is an entirely normal reaction when you're faced with a threat. So you need the energy to fight or fly away from the dangerous situation. But the important thing here is the recovery period that enables the body to recover from the stressful situation. So the initial stressful period is accompanied by a release in the hormones that give you the energy to deal with the stressor. What's really important is recovery. And here in the study, we were able to show that actually there are occupational grade differences in this recovery rate using diurnal salivary cortisol patterns. So cortisol is the classic stress hormone, and it has a very strong diurnal profile. So as when we wake up, our stress levels, our cortisol levels shoots through the roof, and it's supposed to come down to almost zero by the time we sleep. And this is showing the recovery rates are very different for the high grades and lower grades. So the lower grades have a much shallower recovery rate over the day compared to the high grade civil servants. So pointing to what I think to be the research gap is, if you're coming from the biological stress literature, a lot of the stress literature is about adaptation. It's not that every time you encounter a stressful situation, you will always have the same stressful response. Our body does adapt to these kinds of repeated stressors. So that's the normal adaptation that we should be seeing. Our brains, our physiology should be adapted to recognize that, I've met this threatening encounter before, and I shouldn't be having such an adverse reaction to that. So that's denoted by the red line over here. But in certain situations, people do not adapt. They have a prolonged response, prolonged cortisol response to the stressful situation, or there's no reactivity at all, an inadequate response. And these are the situations I really want to focus on, because in order to understand these kinds of repeated measures of the stress response of the hypothalamic pituitary adrenal gland axis, the HKU axis, we really need these repeated measures of these stress biomarkers. But most surveys just do not have these kinds of repeated measures collected on those timescales. And so they do very sort of crude things like sum up the levels of high or low stress biomarkers, which make it really hard to distinguish between people who have an adaptive response and people who have an inadequate response to those stressors. So let's look in a little more detail in that. So here at the top, we have the stressor that generates the stress response resulting in the release of cortisol, and that subsequently has a lot of physiological effects like inflammatory and metabolic effects. And the key over here is this negative feedback loop that tells the brain to switch off producing more cortisol once that stressful situation has passed. So that's the normal adaptation process that if we had repeated measures of cortisol collected over time, it should look like this. But you can see that modeling this in a standard format when you have just one measure of cortisol is a nightmare, because first you have the positive effect, then you have the negative effect. So how do you model this? Then you have the prolonged response situation where you don't have this negative feedback anymore. So you have a situation that looks like this. So a prolonged response, prolonged cortisol activation in your physiology. And then you have the inadequate response, where the stressor doesn't generate a cortisol response, but you have this strong negative feedback loop. So that's probably represented by this middle line inadequate response over here, where there is not much reactivity over time. So really, you can imagine modeling this using standard sort of regression modeling approaches is really hard, because standard regression modeling approaches just assumes that the effect of the stressor on the outcome on cortisol is the same throughout the distributions of your outcome variable. So we need to look at different kinds of modeling approaches, like quantile regression modeling approaches, which really emphasize looking at the outliers and seeing that really it's the outliers that are really interesting here, which can show perhaps differential effects across the different distributions of cortisol. So really, we need to go beyond looking at average effects. We should look at the extremes and the outliers when we're talking about dysregulation in our stress responses. And so especially when we're talking about concepts like allostatic load, it's really at the higher end of this physiological wear and tear distribution that we would expect to find associations. So the overall aim I had was to look at different HPA axis responses to a socioeconomic stressor, which is wealth, household wealth, and then validate this in terms of whether this predicted physiological health in terms of inflammation and blood sugar. And so the empirical analysis was using data from the English longitudinal study of aging, which is a longitudinal panel study of men and women aged 50 and over. And in wave 6 of the study, which is about 2011, hair analysis was collected for around 5,000 individuals. So they couldn't collect more because we ran out of money. But hair is my favorite biomarker of stress now. So I used to work a lot with salivary cortisol. Now I work with hair. Hair doesn't have this diurnal issues. As I said, the diurnal issue with salivary cortisol makes it really hard to tease apart associations, to tease apart effects. But hair is nice because it measures 2 to 3 centimeters at the vertex of your head, will get you about 3 months exposure of chronic stress of cortisol. So it's measuring a sort of an integrated exposure to your chronic stress over a long time period, over 2 to 3 months. The other key variables was household wealth grouped into quintiles, perceived stress. This is a standard question asked for the well-being survey questions, if you know the well-being survey questions. So the anchoring here is very important, yesterday, and it's a scale from 0 to 10. And the physiological measures are inflammation and blood sugar. So this is a distribution of cortisol by the poorest and highest, poorest and richest groups. So the poorest groups are denoted in red over here, and you see that they tend to be overrepresented, not just in terms of the high-end distribution of cortisol, but also perhaps at the low-end distribution of cortisol. So in terms of association, so looking at the association between household wealth and cortisol, on the right-hand side, we have the standard linear regression model where we have cortisol as a linear regression outcome. And on the left-hand side, we have the quantile regression outputs. So with the linear regression outputs, we can see that for the poorest group, the poorest household wealth, they have significantly higher levels of cortisol compared to the other groups, but it's not a very strong association. You see much stronger associations when we look at the quantiles at the highest quantile, so quantile 80, a much stronger effect of being in the lowest wealth category compared to the other categories, as well as a fairly strong association effect of living in the lowest wealth quantile for those in the quantile 20 of the cortisol distribution. I couldn't find any evidence of an inadequate response. So an inadequate response would be basically a flat line. And for all quantiles, you do see an effect of being in the lowest wealth category and having higher levels of cortisol. So the idea here is perhaps these respondents who are having a cortisol response in relation to their low wealth category, but they're in the lowest part of the cortisol distribution. Maybe they're adaptive. They're adapting to their low socioeconomic stressors. And maybe these people over here who have a very high cortisol response, so they're in the quantile 80 of the cortisol distribution, but also having low household wealth, maybe they have a prolonged response to socioeconomic stressors. So here we're really looking at the adaptation hypothesis. So this graph is a little bit confusing, but we've got inflammation on the left-hand side and blood sugar on the right-hand side. On the x-axis, we've got the cortisol distribution going from very low to very high, and the colors are different groups of household wealth. So the light blue is the poorest group, the purple is the richest group, and you can pretty much see there is a socioeconomic difference in inflammation as well as blood sugar. So those in the richest groups, they have the lowest levels of inflammation and they tend to have the lowest levels of blood sugar. And those in the poorest groups, they tend to have the highest levels of inflammation and the highest levels of blood sugar. But what's really interesting is the interaction between household wealth and cortisol. So if you are poor, and in the highest part of the cortisol distribution, you have a double whammy. You have much higher levels of inflammation and blood sugar than you would expect from just the distributions of either variables itself. And if you're poor, and you're adapted to your poor circumstances, that is, you have a low cortisol response, your levels of inflammation are pretty much at the average levels for the entire population. And somewhat similar associations here for blood sugar, although not quite as stark. So a little bit of evidence here of some adaptation to people of low wealth people to their socioeconomic stressors in terms of having a low cortisol response corresponding to low levels of inflammation and blood sugar. So I repeated this looking at the measures of perceived stress. So this measure of perceived stress, I have to say, is much better than the one I showed you from the civil servant study. So the anchoring around yesterday is really, really important. So in terms of correlations with cortisol, there's just no correlation at all. Look at the scatter plot between cortisol and feeling anxious yesterday, just no correlation at all. Although, if we look at the quantiles, we start seeing an association between the highest quantiles of cortisol and the highest levels of perceived stress. In terms of the wealth distribution of perceived stress, it kind of follows the cortisol distribution. So the poorest groups do have higher levels of perceived stress, but it's kind of flattens out for the other wealth categories. And in terms of the adaptation hypothesis, not quite as stark as a difference as we saw with cortisol. So no evidence of adaptation for the poorest group over here in relation to inflammation. Maybe a little bit of evidence of adaptation for the poorest group in terms of blood sugar, because they're if you're in the poorest group, the lowest wealth quintile, and you have low cortisol levels, you have, not the lowest levels of blood sugar, but certainly not as bad as the poorest groups who have the high cortisol response to their socioeconomic stressor. So just to wrap up, I want to say that I think stress is a really important explanatory factor for social inequalities in health. It's definitely not the only one, but I think direct physiological, biological effects of stressors and perhaps perceived stress are important. We should not be conflating the two. Perceived stress is very different from biological stress. And if we're working with biomarkers of stress, we really need to abandon standard models. We really should be looking at outliers, because that's where all the interesting stuff is happening, stuff that's happening at the extremes of the stress distribution. And what I think is perhaps undersold in the literature is that we don't talk enough about adaptation, about resilience. So I know resilience is a really bad word for a lot of people, a lot of research, but I'm conceptualizing resilience as positive adaptation to the socioeconomic stresses. So what we don't know is what enables people in low wealth groups to have an adaptive response to their stressors. And we weren't able to find out about this before because we didn't really have the tools to measure it, but now we do. So thank you everybody for listening. Thank you.